So, with no more ado, I would like to turn it over to Tim, who will talk about rebuilding MSDN. Thanks for listening, Chris.
So I really like the right after lunch slot because everyone has just eaten and sat down again, and all the blood's rushing to your stomach, and you're feeling tired. And I find that it really just takes the pressure off. Yeah, I came to talk about work that we're doing at MSDN to kind of rebuild our infrastructure. That's primarily what I focus on these days. It's kind of funny with these DevCons. When you do a lot of conference talks, you really, at some point, get tired of writing slides. But Chris is really strict about people turning in slides. And it's kind of funny, because every time I come to one of these, I talk on the second day. And having listened to talks in the first day, by the time I get to the second day, I really wish I didn't have those slides, because I wanted to talk about something else. Luckily, there's a big part of this. I mean, one of the things that came up yesterday that a lot of people asked about was some of the stuff that Don said in the about schema, right? And what is the role of schema? And I got a sense from a lot of people that they were perhaps taken aback by some of the statements he made. I got some responses from other people who said, yeah, I think that's right on. I actually really agree with Don. One of the things, so I work for MSDN in Redmond. I live in New Hampshire, and I telecommute. And when I'm in Redmond, I sleep on Don's couch. So we spend a lot of time hanging out together and talking about this stuff. And it's really fun, because while he's off kind of figuring out where certain projects at Microsoft should go in the multi-year time frame, I try to take the opportunity with the work we're doing at MSDN to actually put a lot of the ideas for where things are going into practice now, because it's a great feedback loop. So it was pretty interesting yesterday. Don was talking very much from a deep meditation and philosophical perspective. David Ng spoke later from a very we tried to do this and this is what happened perspective. I'm lucky enough in my role at MSDN to kind of bridge those two worlds. So I want to talk first real briefly about what it is we're doing. MSDN is really an invaluable resource. Our customers tell us that all the time. There's a lot of things that people really like. There's a lot of things they don't like too. The biggest thing they tell us though is we really use this day in and day out to find information. We need to do our job. So please try to keep it. Yes.
Love MSDN.
Thank you.
Broken links.
Yes. Okay. I'll put all the dirty laundry out here, right? The plumbing's really old. It's tied to the production of CDs. It's also tied to the production of documentation sets from product team, which is the major cause of broken links, because when a product team decides that it wants to rework the file hierarchy by which it produces its documentation, that translates directly into impact on our URLs. There's a plan in place to fix it. It's going to take several steps to get there, because there's a lot of plumbing to retool, but we will get there. And I'll show you an example of that, so the first step towards that shortly. Broken links, discoverability, there's a lot of problems there. You've been seeing a lot of new stuff from us lately, these developer centers. These are new faces designed at focusing in to help people find information about a particular topic. However, this is really, it really is just a new face. I mean, they're very, very useful, but the stuff that's underneath them, if you ever look at the URLs on those sites, a lot of people, it just makes them cringe. That's because we really didn't have an alternative given the underlying platform that we had to build on. So what's happened, the way I actually ended up doing what I'm doing now is I was involved in building the first one of those new sites. And so I felt all the pain of what we could and could not do on top of the existing bits. And so I realized that the thing I most wanted to do was go rebuild those bits. So we're in the process of building a new foundation that optimally will allow us to do all kinds of interesting things. We're doing a lot of it with XML. And so the original plan I had for this talk was to, I have prototype code running on my system for a new publishing pipeline we're working on that's XML based. And I really just wanted to start a debugger and walk through that and show you what we were doing and why we're doing it that way. It turns out that the very first piece of that is all about schema. And given the whole kerfuffle yesterday about schema, I thought, We'll go through the pipeline, but we may not make it all the way because we're going to spend a little longer time on what's going on with schema and why. And then if there's some stuff at the end you're really interested in, if we don't get to that, you could just come up and ask me. Okay? So the system that we're using, or the system that we're building, defines much of its content, not all of it, but much of its content using XML formats defined in XSD. And I know that there's a lot of contention about, what is the right role of XSD. There's some people who are really against it, some people who are for it. My feeling about it has really changed over time. Is Aaron here somewhere? Aaron's back in the corner. I was thinking about this talk earlier, and Aaron wrote the original XML classes at Developmentor, and once a long time ago, he sent out mail about the class, and I responded in a rash moment and criticized something that I really had absolutely no right to criticize. And Aaron said to everybody on our internal mailing list that that was the case, and he was really right. So in order to atone for my transgression, I went to his Gorilla XML class, and I charged he and the other instructors with making me fall in love with XML. I really wanted, because I was teaching a lot at the time, to leave that class being unable to do anything other than go work with XML. And it took him till about Tuesday noon, which, just as an aside, had to do with XPath. For some reason, as a guy who's written a lot of code that traverses object hierarchies, I find XPath and SQL just so attractive. I'm so tired of writing for loops and if statements. I really love these languages that express that really concisely and have an engine that does all that gunk for me. That's another story. Anyway, later on I got to schema, and I went through this phase where I really believed that schema was going to revolutionize how people dealt with XML, that it was all going to be about types, that this post-schema validation info set, people were going to code against that, and oh my God, it was going to be this huge change. Man, was I wrong. I spent a long time working on mappings between XML and object stuff. I did it for a while for interop stuff, work that was going on at Iona. I did that before I joined Microsoft. I did a lot of it for Chris. Chris would always naysay XML because there's a guy that we work with who talks about the /dot problem. It's got nothing to do with the site, right? Of course, we love the site. It's the difference between some people want to say person/name in XPath, and some people, like Chris, want to say person.name in C#. And so I spent a long time thinking about models for getting, guys like Chris, who, frankly, he's stuck in the land of curly braces. And I was looking for ways to make Chris happy with XML. So I did a lot of type mapping stuff, and the problem is that trying to do 100% type mappings between the CLR and schema and make it bidirectional and round-trippable, I'm totally of the opinion that it's a fool's errand, right? I think that you end up with a model on both sides that only a mother could love, and then only because she's compelled, right? It's just hideous. So I've really changed how I look at schema, and I'm going to show you in a little bit the schemas that we're using in this system because they reflect the ideas. And it really is this notion that Don talked about yesterday. So I really don't now look at schemas as a type system. I look at them as templates. In fact, it's really ironic because back when schema was coming out and people were kind of moving away from DTDs for legitimate reasons, there's a number of issues with DTDs. People used to say, oh, well, DTD, it's really not a type definition. There's no type. It's really a template, right, for what your document's meant to look like. Type is kind of a misnomer. Ironically, I now look at schema and say it's really about templates, right? In a lot of ways to me, and again, I'll give you an example later, I tend to think of schemas now as being, or at least the way that I use them, is very much like DTDs, except that there's more structure around hierarchy, so you can have elements with the same name, and there's namespace support, right? So I'll talk more about that when I get to those. But this is where I really wanted to kind of deviate from the talk a little bit. How many of you are COM programmers? A bunch of folks? So I could do this example with COM or with .NET. The advantage of the .NET example is I could actually compile it and run it. It's been a long time since I did all that COM goo. I wrote it all down so that I didn't have to remember it. So let's just do it in .NET, right? If you think about But using the variant type actually in COM as a springboard, right? People wrote a lot of code that took variants as arguments. And what is really a variant? Someone sends you a variant. What is it? Anything. Well, there are some constraints, right? It's 8 bytes. Although later on, it turned out that those 8 bytes could be a pointer to some memory and a pointer to a record info that described what was there. So it could be more than that. But let's ignore that case, right? It's basically 8 bytes that somebody sent you. So you would have a function that took a variant. And all you knew was that 8 bytes arrived in your function. And so what did you do with that variant if you wanted your code to be reliable? You check the type. So let's do actually the same thing in .NET. So look, I happen to have a little, I have a little window here. I've been switching forth between VS and Emacs. Control P means different things. So let's write a, let's do this. Let's make a value type. Yeah, I can see it perfectly, but all right. How's that? So we have a value type, and I'm going to treat this as being just like variant. Type just says, you know, I've got some value it is, and I'm going to pass that into a function. Actually, before I do that, let's write one other quick function. I'll just static int double int 1 int I. We'll like that. And we'll return I times 2. And we'll say console.writeLine double int. Hey, actually, we'll take off. We'll do that. And we'll pass 5 in there. Right? And what that does is pretty obvious. The log algebra, or arithmetic rather, hold. And that should print 10 in business. Okay? But let's assume that we didn't type thing as integer. So let's have another function. We'll still make it return an integer for simplicity's sake. But let's write another function that takes just a value type, right? This was a style that a lot of COM stuff worked in, where I passed a variant, right? I had some flexibility here. What do I want to do in this function? I'm going to check the type. So we're going to say if vt get type equals type of int. It doesn't equal type of int. What should we do? How about throw new argument? I expected an int. Right? And then if that's the case, we can take this and say int vt. Now if we change that, should that work? I hope so. I think so. And so if we walk in there, we say, is it an integer? Hey, it was. Let's pop out of there and print it. It's 10. And of course, if we change this to a character, for instance, note that it still compiles, right? Because a character is a value type. So it's legal in terms of the checking of the signature. But what's going to happen when I walk in there? I'm going to throw the exception because that thing's not an integer. All right. Cool. What does this have to do with what does this have to do with schemas? Well, the key is that in the function, right, we are being handed stuff, what the stuff is. So we assert at this moment the stuff must be an integer. And if it's not, we're going to fail. Right? And a lot of variant code was written that way, especially if you were consuming that stuff in C++. Right? So if I was writing a COM component in ATL, someone's going to hand me a variant, probably I'm just going to say, is this an integer? Because if it's not, go away and stop bothering me. That's because I'm uptight being from the East Coast. There was an alternative, however. What might I have done with that variant? What might have been friendlier for my caller? I could try to convert it to what I expected. right? So there was a function called variant change type that allowed you to say, well, whatever you had sent me, is it what I wanted? Right? And it doesn't matter, actually, if you sent me a string. If I could turn it into an int, then that's what I wanted. Right? So there's actually a lot of flexibility there. Can I write a function that does that here? Sure. What would it look like? Yeah, we could use, sorry, go ahead.
C type in the function.
We could if we were in that other language.
Convert that.
Yeah, we could use convert. So we could say vt equals convert to int 32 vt, right? And then if it's still not an int, because it couldn't be converted, right, then there's going to be a problem. So in fact, if vt equals null, which is the only possible outcome, right, then we're still going to say, not really I expected an int, but I expected something I could change to an int, right? And otherwise, everything else is fine. So now, if I change this to 3, what's going to happen when I run that? It's not going to be 10. That's true. What's it going to be? What's the ASCII value of numeric character 5? 53? 35? It hacks. So it worked. And it was doubled 106. It was 53. Decimal. Yeah, absolutely. All right. So the point is, we had the function say, I want, I'm going to try to make this thing into what I want. Now, the interesting question is, you know, all these things deal with value type, and they, or the bottom two rather, deal with value type, and they approach what they do with it very differently, right? One says, I'm going to assert that you must have sent me int. The other one's saying, I'm going to assert that you must have sent me something that could be turned into an int. And I doubt you ever wrote value type code like this. I know I didn't before I started thinking about this problem. But a lot of you wrote variant code like this. Yes? All right. So now here's the question. For those of you who passed variants around, how many of you ever passed around a record set? It's OK. You're among friends. I don't mind. Or here in .NET, what if you passed around a data reader or data set? So for those of you who've ever passed that kind of data around, it's really like this value type. You're saying, here's a bunch of stuff. It's not a single value. There's more to it than that. But here's a bunch of stuff. And inside your function, you did something with that stuff. The question is, what did you do? Did you write code that said, before I start walking through here, I'm going to look at the collection of fields and assert that they are, in fact, what I wanted? Did you write that code? No, you're shaking your head. What code did you write?
I just write code to make sure that the base structure, in this case, the record set, was in fact a record set.
Well, you know that it's a record set, but did you check, like, if you were pulling out names and addresses, did you check that it had a first name and a last name? No, you probably, you propagated it through your system to the UI, and then the UI said, I think there's an address because I have to paint this field. Oh, crap. Right? And so any change back in the system that altered the structure of that thing broke something way up in the front because people didn't write this code. Why didn't they write that code? Why didn't you write the logic that checked the fields?
Not my problem.
Not your problem. I actually have a different reason. There's no easy way to do it. It's not like, oh, hey, what's the type of this thing? There's no language for expressing the type of a data set or a record set, right? There's no language to say, I expected this structure of data. Strongly typed data sets, yes and no. I mean, that stuff is really a veneer that does the coercions when you reach into it. So at that level, it's kind of, it's really the same thing. There's not that much difference between a strongly typed data set and accessing a field and casting, right? It hides the cast from you, but if the format is the wrong format, you're toast, right? So people didn't write that code to check those things because there's no really easy way to do it. Now, I used to believe that with .NET, a lot of people would stop handing around data sets and iData readers because I, for a while, believed that people handed around record sets in COM because they marshaled by value. And that was really useful. And it was hard to make objects that marshaled by value in VB. So I thought, you know, when everything just serializes automatically for you in .NET, everyone's going to switch over to using objects. They're going to take their data out of the database and populate these object models and pass these things around. And I was dead wrong. And the reason I think I was dead wrong is actually that getting the raw data is really useful. I mean, look, as an abstraction, if I need to get data from there and put it on the screen over here, there's no particularly compelling reason in the simple case for going into a set of objects, right? I think the reason the data set and the record set and the data reader are so popular is people understand them. Like, I got some data, I need to put it over here. Great. To me, that's actually really where XML comes in. And so the interesting thing is, if you imagine these functions written with a data reader, or a data set where people don't write this code, they just keep their fingers crossed, right? It's what a friend of mine once called Marshall by Gamble. You know, what happens when we pass XML around? It's really the same problem, yes? So if I pass you a DOM or an XML reader or an XML an XPath navigator or whatever I pass you, it's the same situation. I've said, here's some stuff. Now, what are you going to do with it? Well, optimally, you're going to check to see if the right stuff is there. There's really three choices, right? You could say, I'm just going to assume the right stuff is there. It's a very dangerous business. You could say, I'm going to check that the right stuff is there. Or you could say, as we do in the last case, I'm going to try to turn it into the right stuff.
At some point, any developer is going to have to address whether or not the package that they got is valid. They're going to have to check to make sure those fields are there, that they've got the right value pairs, and see what the XML structure. So you're just talking about at what point you do that checking?
At what point you do the checking and how you really do it. So you look at these two functions. These both do the checking, and they both achieve the same result, but they took different approaches. This one said, I have a certain expectation that you send me an int. This one says, I have a different expectation. I can pass the same value to both of these, and they both assert different things about it because they're coded in different ways. So imagine that I send you some XML, okay? I have two observations now to make. First, there's any number of ways that you can ensure that that stuff looks right. You could write XML reader code that walks through it and says, this is what's got to be next. That code can be tricky to write, especially if you have a pretty complicated format, but the advantage is it's really fast. It's way faster than schema validation, and it's way more efficient than putting in a DOM. Right? So that's one way to do it. Another way to do it would be to put the thing into a DOM and walk through the DOM and assert that it has a certain structure. A third way would be put it into a DOM and execute a bunch of XPath expressions against it. Another way would be to validate it with a schema. So I tend to look at schema validation as it is one of many techniques that I could use to assert that the XML I just got looks a certain way. These other schema languages, RelaxNG, right? Schematron, those are yet other ways to assert that the XML looks a certain way. But here's the key thing. How I want the XML to look and how you want it to look could be different. Right here, how double int 2 wants a value type to look and how double int 3 wants it to look, it's different depending what they're doing. So maybe I'm writing a function that takes XML and is going to store it in a file. I could care less what it looks like. Maybe I care that it's a SOAP envelope. So all I'm going to do is say validate that the root of it's a legal SOAP envelope. I don't care what's in it, just store it there. Maybe it's going to say I really require exactly this layout. But the point is, it's about what I expect the XML you're giving me to look like to proceed. And a lot of people spend a long time with namespace, especially saying, if you give me XML, how do I get the schema to verify that it's right? I actually don't care that the XML is what you say it is. I care that it's what I need. And what I need actually varies across my system. So we find ourselves, let me give you the real concrete example where this has got us in MSDN. We have this publishing system, and we need it to be flexible in the face of new kinds of content. So we want a pipe that is very open for new stuff to come through. But at some point in the system, we have to kind of branch and say, hey, it's a technical article, these rules have to apply. Or it's a shared image or a seminar or whatever, these other rules have to apply. So when I set out to design this thing and say, I'm going to define these structures for this information, one of the formats I had to define was for a file called a manifest. Let me open up a manifest. have one in here somewhere. So this is what a manifest looks like in our current prototype code. And this happens to be a manifest for a technical article. And really, this just lets us capture a whole bunch of information that we need to be able to publish this thing. So there's a bunch of categorical description information. What's the audience? What programming language does it use? There's stuff like who's responsible for this if we have to go find them. What's the contact name? Where should this thing be linked from our sites? What should the headline be? Or what's the headline, et cetera, et cetera. It's just a bunch of data that we need to push this stuff through our system, right? So I started out by saying, well, we really want a type that defines like the abstract idea of a manifest. And then these layouts differ depending on the kind of content you want to publish, right? If you're publishing some kind of binary, we're not going to say, oh, it has these GIF files as part of it, right? We really only need to do that for pages, for technical articles. So the layout of these things will differ really depending on what we're publishing. So the first cut at that was like, hey, there's this base type, you know, it's for a manifest, and then there'll be these derived types, and on we go through the system. Okay, fine. So I got this type hierarchy. It derives by restriction. This could be a very open, like you've got to have this stuff, then what comes after is really a wild card. And I'd have these different subtypes that narrowed that down and said, okay, it's got to look exactly like this. Well, so the thing that kills you, or killed us anyway, was versioning. Because as soon as we had that type hierarchy, right, and everything's got one base type, as soon as we say we want to take this piece to version 2, we have to have another hierarchy. And we have to repipe our system end to end. And the thing is that that's not a requirement of XML. That's a requirement of schema and how we were trying to use it. Because with XML, hey, I could move this middle part, and I could use transforms or any number of other techniques to bridge between them. Right? So we really ran into this very brittle aspect of trying to use the nominal typing and type derivation in schema. And guess what? As my friend Martin Gudgeon, who spent a very long time on the schema working group, observed, it's no different than any other type system, right? The idea that, you know, oh, people look at it and say, geez, trying to use the Corba type system or the COM type system or even the Java type system across the wire, it's really brittle. Guess what? The fact that it's a schema type system doesn't make it any less so, right? I mean, it's another description of data, and if you try to maintain these hierarchies, for us at least, versioning was a killer problem. So we really had to go back. I mean, what fundamentally happened was we had 3 colliding dimensions. We said, you know, there's this abstract type in this derivation by restriction this way. Then there's versioning that way. And then kind of off in some other direction, there's composability, because these things come from different namespaces for a variety of reasons. And we looked at that for a long time and said, trying to define a type system that is restricted, extended, and composed, you know, blah, forget it. It's crazy. Right? It's just not going to work. And the thing is, as I said, these are schema problems, not XML problems. So the question was, how do we want to use schema in a way that's much more in line with how XML really works? And going back to my comments earlier about envisioning a world where people really programmed against schema and against type, about PSVI, you know, I've come to realize over time, I'm an XML developer, and I never do that stuff. I do not want to have to, in the course of processing a document, say, now wait, what type is it? Right? There's a really scary phrase in the schema spec about, you know, PSVI contribution. And at one point, I wrote a document around some graph stuff, how you take a graph and put it into an XML document. And I found myself writing language like, you know, this elements or this attributes schema contribution has to include global element or global attribute information, right? Nobody programs like that in XML. They just don't. So the question was, how do we start to use schema in a way that A, lets us assert what we care about when we care about it, and B, is flexible in the face of it changing individual pieces of the system? And it led us to a model that is pretty different from the mainstream. So let's go look at it.